Okay, good morning, class.
Good morning, sir.
So at this point, we're looking at the November 2018 paper 1. We got up until question 5.5.3. Did we answer this question? No. No, we haven't answered this question. Okay, so this question says, where's x times g of x, which is the function g, be greater than 0? So we said that for that to be the case, for something to be greater than 0 means to say it must be positive. So under what condition when we're multiplying two things is it positive? If both is positive or both is negative. So if we look at this graph here, the g of x graph, which is this one here, just do it here on the side. So that is your g of x graph. Okay. You see on this side of the origin, this is where x is less than 0, where x is negative. Can you see that? On the other side is where x is positive. So the bar must be negative and the graph must be negative. Can you see that? And is that the case here? Yes. The bar is negative and the graph is negative up until 0. Then what do you notice from 0 to 3? One is positive and one is negative. That's not what I'm interested in. However, on the right hand side of 3, that's again the case. One is positive and the bar is positive and the graph is positive. Can you see that? So in other words, is that a continuous or break-in solution? Break-in solution. So in other words, x must be less than 0 or x must be more than 3. Can you see that? So for this answer here, x must be less than 0 or x must be more than. Okay. You guys understand? Then the next question says, let's take this one from here. Five 5.7. Still on that graph, no? Pull this up. It says T is the point on the x-axis and M is the point on F such that Tm is perpendicular to the x-axis, as shown in the diagram there. Tm intersecting G at P, calculate the maximum length of Tp. Okay, so for the maximum length, for the length of Tp, how do you calculate the length of Tp? How do you calculate the length of Tp? The top graph minus the bottom graph. Not so. So for Tp is going to be, which graph is on top? G of x. There's going to be the G of x graph minus the f of x graph. Can you see that? So if I look at the G of x graph, it's going to be 2x minus 6 minus f of x, which is x squared, minus 2x minus 3. Can you see that, people? Whenever you're working out the distance between two graphs, the top graph minus the bottom graph. Okay. That simplifies into negative x squared. That will be plus 2x, so it will be plus 4x. Plus 3 minus 6 is negative 3. So that is Tp, the length of Tp. Sorry, not Tp but Pm. Why did I say Tp? Calculate the maximum length of MP. MP. What's wrong with me this morning? Many things. I'm doing the right calculation, but I'm writing the wrong what's in it. I'm calculating PM. Sorry. you guys make the same mistake in the exam, I'll give you 4 marks. Okay, now if you get, now the thing is, if you get 4 marks on your paper, then I think I will take that 1 mark. Alright, but anyway, that's how it goes. So PM is that length there. So what you notice, what we are left with, this model's a quadratic pattern, a quadratic model, not so. And it is negative, not so. So that means to say that the quadratic will look like that. It will have a maximum value. Does it make sense? So how do I get that reading? I complete the square. So I take out negative as a common factor, so it's negative into x squared minus 4x plus 3. So what must be added here to complete the square with? I thought some of you would have shouted out now at this point. 2 squared is, which is 4. Some of you did a lot of this over the last couple of days, not so? So it's going to be x minus 2 squared minus 1. So we multiply that in, we get negative into x minus 2 squared plus 1. So what's the question? The question says, calculate the maximum length of the MP. So we conclude, therefore, the maximum length of 1 unit. Then ask you which value does it occur at. We would have occurred at an x equal to 2. Okay. Any confusion there? Okay. Is that correct? Nice. I'm feeling better. Next question. Here we are told, let's take this off here. What was this length of B3, no? Is that 3 and 0? No. Yeah, 3 and 0. No. If it's a reflection about the line y is equal to x, y is equal to 0. People, if something is reflected in the line y is equal to 0, what else is this line y equal to 0? It is your, this y is equal to 0 line is what? Your x-intercept. Not so. So if something is reflected in the x-intercept, what happens? Y becomes negative. Okay. So it says f of x is reflected, bring this up a bit. F of x is reflected about the line equal to x in the form of px is equal to dx squared plus ex plus f. Now what form is this? It's quadratic. Can you see that? The standard form of quadratic equation. Write out the equation of p of x. So we say that if something is reflected in the x-axis, y becomes negative. Okay? So we have negative y is equal to x squared minus 2x minus 3. You divide by negative, so y is equal to negative x squared plus 2x plus 3. And that is your equation of p of x. Okay, as you can see, it's your equation of p of x. Okay, why do you think they put a dx squared and the ax and a f here? Because they have used f of x equals ax squared plus bx plus c. Can you see that? So if they had to put here again, if p of x equal to ax squared plus bx plus c, in the same sum, the value of a has to be the same value of a. Can you see that? We use b again in the same sum, and that means to say that the b values are the same and the c values are the same. That is why you will see go dx squared plus ex plus a. Makes sense? Then the question says in 5.7.2, what are the coordinates of the maximum or minimum of this function? State whether it's a maximum or minimum. So if something is reflected in the x-axis, this is what the graph will look like now, okay? It will, this 1 and will go there, 1 and 4, because the y becomes negative, and that's what the graph is going to look like. It's actually going to go through about in the same length as that is there. Okay. So the question is, what's the coordinates of the maximum minute? So the coordinates is what? The coordinates is 1 and 4. This is now your turning point. Why? Because if something is reflected in the x-axis, y becomes negative. So negative 4 becomes negative 4, which is positive 4. So does this graph have a maximum minimum? Therefore, P of x has a maximum value of what? Of 4, and occurs at x equal to 1. Okay, that's basically the coordinates of the turning point. Okay, put it in here a bit. Let's see. What's the question? Okay. Question 6. In question 6, we are given f of x equal to negative 3 over x plus 2 plus 1 and g of x equal to 2 to the negative x minus 4. Write down the asymptotes of f. So you got two asymptotes here. Besides our curve, you've got a horizontal and a vertical asymptote. The one is y is equal to 1, which is coming from there, and the other one is x is equal to minus 2. Or you could have said that HA, horizontal asymptote, is 1 and the vertical asymptote is negative 2. Same thing. Okay, VA and HA. Alright. The next question, let's close this. The next question, 6.2, says write down the range of g of x. So what type of graph is g of x? It's a decreasing exponential function at a y value of minus 4. Okay? So what's the range of this graph? Y must be greater than negative 4. Okay. That is also the equation of your asymptote, which is y is equal to minus 4. Okay. Let's pull up the next question. Let's take it off here. 6.3 says determine f of minus 3. F of minus 3. F of minus 3 equals negative 3 over minus 3 plus 2 plus 1. So it's going to be minus 3 over minus 1, which is positive 3 plus 1 is 4. All agree with that? The next one says determine x if g of x is equal to 4. Now that is g of x, not so. So g of x is equal to 4, which means now to say that you got 2 to the minus x minus 4 is equal to 4. You take that 4 over, becomes 2 to the minus x is equal to 8. 2 to the minus x can be written as, 8 can be written as 2 cubed. So minus x equal to 3. So x is minus 3. So what do you notice with 6.3 and 6.4? Same x value. Can you see that? And we have the same y value. Can you see? G of f of minus 3 is 4 and g of minus 3 is also 4. So what does that mean? Point of? And that's one of the points of intersection. Okay? If not the only one. Alright. So just remember this. I'm taking it off so that I can keep this information in focus. Then the question says sketch. Okay. Here we are told that sketch the graphs of f and g on the same set of axes, clearly showing all intercepts of the axis and the asymptote. Okay. So let's look at the f of x first. Remember we had two asymptotes here. It is horizontal and the vertical asymptote. That is y is equal to 1 there. And we have x is equal to minus 2. Okay. Then we didn't work out our x-intercept. So x-intercept, let y equal to 0, not so. Let y equal to 0. So 0 is equal to minus 3 over x plus 2 plus 1. So you get over the equal sign becomes 3 over x plus 2 equals 1. You cross multiply. So x plus 2 is equal to 3. So x is equal to 1. So your x-intercept is at 1. So what do we do thereafter? We work out our y-intercept. How do you calculate y-intercept? We let x equal to 0. Okay, so f of 0 is equal to negative 3 over 0 plus 2 plus 1. So that's going to give us negative half. Okay. So the graph is going to come through there and like that. And which also confirms that we're in the right quadrant because that is negative. Can you see that? Then on the other hand, we got the g of x graph. And the g of x graph is x-intercept, let y equal to 0. Okay. So you got 0 is equal to 2 to the minus x plus 4. So you get over the equal sign. Now it's minus 4. So you get 2 to the minus x is equal to 4. So 2 to the minus x is equal to 2 squared. So therefore minus x is equal to 2. X is equal to minus 2. There's now minus 2 here, so that is on that point. Okay? Then we work out the y-intercept. How do you calculate your y-intercept? Let x equal to 0. Okay? So g of 0 is equal to 2 to the negative 0 minus 4. So g of 0 or y is equal to negative 3. Okay, so what else do we know? We also know that this graph has an asymptote at y is equal to negative 4. No? Extending there a bit. Okay, and as we know, it's a decreasing exponential function. Okay, and this is your g of x graph. Now, what was that point of our intersection again that we just worked out? Negative 3. Can you see it's on the side? It's about negative 3 there and 4, which also confirms that the calculation is more or less correct. Can you see that, people? Did I ask us to draw that in? No. So did I have to? No. Okay. But I'm just showing you, as we mentioned, it was a point of intersection. Just to put it in the graph. People in 6.6, the question says determine the equation of the axis of symmetry of F. Determine the equation of the axis of symmetry on F, which has the equation y is equal to. Determine the equation of the axis of symmetry with F. Where m is less than 0, which means to say m is negative. There are two axes of symmetry. Y is equal to x plus c and y is equal to minus x plus c. So if m is less than 0, it means to say it is negative. So it's going through this point here. So it's that one there. Y is equal to minus x plus c. And of course we substitute the point of contact of the two asymptotes, which is negative 2 and positive 1. X and y. So 1 is equal to negative minus 2 plus c. So that is 2, you take it over, becomes minus 1. So we have y is equal to minus x minus 1. And that's the answer that you can put in for 2 marks. No. Okay? Any confusion there? No? 6.7. So what I'm going to do is I'm going to take this off here. Right. Pull this down a bit. Let's see. In 6.7, a new graph of h of x is formed when g of x is reflected above the y-axis and then shifted 3 units down. Okay. 6.7. The graph of h of x is formed when g of x reflected by the y-axis. Something is reflected about the y-axis, what happens? Reflected in the y-axis, what's the rule? X becomes negative, not so? So, the g of x graph, what's the equation of g of x again? The g of x graph is 2 to the minus x minus 4. So if x becomes negative, it is h of x, or firstly y, equals 2 minus x. The x becomes negative, minus 4, where h of x is now equal to 2 to the x minus 4. So if I should draw this graph and it's reflected in the y-axis, okay, then this point of minus 2 becomes 2. Not so. That point remains that point, the asymptote remains the asymptote. Can you see the reflection there now? In that line y is equal to, in the y-axis. Was this the question to draw it? No. Did I have to draw it? No. I'm just showing you what's actually happening. Can you see the reflection there? Basically that distance about is the same. Okay. My graph is not nicely drawn to scale, but that is the idea that comes into play. Okay. So that's the first question. Come inside. Let's come in. Come in. Yes, sir. Just put the money on the table. Alright, so in number 2 we are told between which two integers will the x-intercept of h of x lie? Measurement. Okay? Oh, it's shifted as well. Sorry. I'm asking now, why did they ask this question? So I went a bit too far here. So here we are told that reflected about the y-axis and then shifted 3 units down. No? 3 units down. So what do? I was supposed to? Minus 3 on the x. So that would simply be y is equal to 2 to the x minus 7. So, that graph that I drew earlier on, there was this graph, and it had to move down by 3 units. You guys understand? So which means to say I have an x value greater than 2, of course. No? So how do I work out my x-intercept? 6.7.2. How do you work out the x-intercept? We let y equal to 0. So we say x-intercept, let y equal to 0. Okay. So if y is equal to 0, I think that was p of x, no? H of x, not p, but h. Okay. Just coming back to this, I know it's a bit messy at this point. Just pull this out here now. Okay. Let's get that part. So your x-intercept at y equal to 0, that is the equation we're looking at. So 0 is equal to 2 to the x minus 7. Take 7 over the equal sign. So 2 to the x is equal to 7. So what do I do now? How do I solve for x here? We can do inspection. Not so. So if I say 2 to the 1, of course it's 2. 2 to the 2 is 4. 2 to the 3 is 8. So 2 to the 2 is 4 and 2 to the 3 is 8. And 7 lies between 4 and 8. Not so. Therefore, what's the question? Between two, which two x values? Which two integers will the x-intercept of h lie? So it will lie between x is equal to 2 and x is equal to 3. That's one way of looking at it. Otherwise, we could have used logs. Did I show you how to use logs already? Not yet, okay? So then that's the way you're going to do it, okay? This is the first. Probably with the current grade 10s have done that lots. Okay, but you guys, some of you that will do, will make it to grade 12. We'll do it. It's only a joke. It's only a joke, listen. It's only a joke. People, you guys are dressed like jokes today.
Sir, but it's to raise funds.
It's to raise funds. So I would also want to raise funds for myself. It's a joke. Right, people, listen. Let's look at the next one. I thought you guys weren't listening, so now I know you listen. Some of you. Okay. People in 7.1. Let's talk about this here. During a survey, out of 25 out of the 40 learners indicated that they are Twitter users. Okay. 2 learners are selected at random from the class. The first one is not replaced before the second one is selected. Okay, now there's a typo there. Draw a tree diagram that shows the possible outcomes of the situation. Write the probabilities of the relative branches. Okay. So in 7.1.1, so on the first draw, we say Twitter and not Twitter. Okay. That thing on top means to say not. Okay. So 24 out of the 40 indicate that there are Twitter users. So it's going to be 24 out of 40. So how many non-Twitter users are there in the same group? 15 out of 40. Not so. Right. So if the first person that is drawn is a Twitter user, then what is the probability of the second draw? How many Twitter users? If you draw the first one to be a Twitter user, how many Twitter users are there in the second draw? 24 out of 39. And non-Twitter users? 15 out of 39. You guys understand? Now if the first person you drew was a non-Twitter user, then how many Twitter users are left? The probability is then 25 out of 39. And non-Twitter users? 14 out of 39. So my outcomes is Twitter, Twitter, non-Twitter, non-Twitter, Twitter, and non-Twitter, non-Twitter. Okay. Did I ask us to work out the end probability? No. If you wanted to, no problem. Okay. The question in 7.1.2 says, what's the probability that of the 2 learners drawn, both will either be Twitter users or both will not be Twitter users? So, in 7.1.2, the probability of Twitter plus the probability of non-Twitter. Not so? So the Twitter is 25 out of 40, I'm following this branch, times 24 out of 39 plus. Non-Twitter is 15 out of 40 times 14 out of 39. Okay. So that gives us 25 out of 40 times 24 out of 39 plus 15 out of 40 times 14 out of 39. Will give you 27 out of 50. Or 0.52 or 51.92%. It's all the same thing. Is that correct? Okay. Any confusion here? No? In 7.2 we are told that a survey was done amongst 50 learners. So, looks like a Venn diagram, and yes, it says Venn diagram there. 50 learners. on the extramural. The results are shown below. 32 plays netball. X takes part. X were part of the Jazz Cats. 10 played netball and were part of the Jazz. Okay. Do we still have Jazz Cats at the school? No. No? What happened to them? To little people. Okay. But we will get there again. No. Okay. So, people, 32 played netball. Did I say 32 played netball only? No. So, that and that adds up to 32. We all agree with that. X takes part in the Jazz Cats, so that is X. 10 played netball and were part of the Jazz Cats, so it's the overlap there. So, how many is here? 32 minus 10, which is 22. 5 did not participate in the Jazz Cats or netball. So where does that 5 go? It's supposed to be no, no? So 5 did not participate in the Jazz Cats nor in the netball. Draw a Venn diagram to represent the given information. So how much goes here by the empty space? Goes X minus 10. You all agree with that? Okay. So there's your Venn diagram for 4 marks. Then in 7.2.2 the question says determine the value for X. 7.2.2. So we know that this whole set here, which is 32 plus X minus 10 plus 5 equals 50. Or I could have said 22 plus 10 plus X minus 10 plus 5 equals 50. Remember, all those parts adds up to the total number, which is 50. Okay. Huh? You want to throw water in?
No. I want to go to the bottom now.
You want to pour water in there?
No, I want to go to the bottom first.
Yeah?
And then.
Oh, you want to do both? Okay. So, people, X is then equal to 50. 50 minus 32 plus 10 minus 5. It's going to give you 23. Okay. So X is 23. So this is going to be 23 minus 10. And what's 23 minus 10? 30. So that goes 30. Then the question in 7.2.3 says, what's the probability that the learner chosen at random participated in at most one extramural activity? At most. So which categories do we look at here? It's going to be 22, 30, and 5. This is what's the probability that the learner chosen at random participated in at most one. So 1 and less. Not so. So that's why I'm including the 5. What did I put in the memo? So I would say the probability should have been 22 plus 13 plus 5, and that's over 50. 22 plus 13 plus 5, that's over 50. 4 over 5, is that correct? Yeah. Even it said, or 80%, no, or 0.8. Even it said, what's the probability that the learner chosen at random participated in one extramural only? Then I would have gone with 22 and 30, the sum there. Okay? But he said at most, so you must take out everything that is less than that. Okay? This is a good question. Then again, all these questions are good, no? No bonus question. Yes, yes. Alright, I thought I was going to, I was working towards that. But okay, you guys got it. How much time do we have left? 15 minutes. Okay, so tomorrow we will then do paper 2. Sure. Yes?
Would you say the
paper, the memo is being written out. We don't have the, at this stage, we don't have the memo for paper 2. Okay? And Egan will be doing that first. Okay? Are you done with paper 2? Yes. So what do you want to do with the memo? You want to mark the stuff that you haven't done.
No, I'm not
That's
done.
strange.
I'm not done with the paper, sir.
So that paper I'm going to do straight on the book.
No,
So
sir.
with that you're going to mark from
No,
what the
sir,
minute.
the thing is, I did.
Are you having a problem with the sum that you have done already?
No, so I did the measurements and the thingy part, so yeah.
Okay, so measurement, let's look at that. Okay, let's just stop this video.
And then physical.